multiple Logitech camera that I've taken apart and placed right there. He's used some erector sets to arrange the tree for the wall. Like I said, the only thing that I really have is that saber-tooth motor driver, and I think costs about $50. The parts to build this, I built this robot with Tamiya gears that I bought at a hobby shop. They were $12 each, and this plastic I cut out with the Dremel, so it wasn't super. And I bought these little casters off some other little thing at the hardware store. I think altogether I spent maybe less than $100 in this robot. Now I've seen similar platforms for sale on the internet. But at the time I wasn't aware of any, so I figured try to save myself some money.
That's a good job.
So, but like I said, there's you go online. There's a new company that's based out of China called DF Robot, and they sell a lot of very cheap robot kits that are mostly Arduino based. They're really reasonable.
Okay, let's do some object avoidance then. Any questions on object tracking? In this case, we chose red. We could have chosen any color. There's a lot of modules over here. Let's see if I can do this.
The only thing I'm curious is, I've noticed that with backing up and going forward, how does it know the distance?
It's this box that is drawn around it, the center of gravity box.
You're trying to center it in the range,
well,
or at a certain level?
We've got a range. What's the variable called for the box size?
Yeah, basically.
Box size. We've got that variable, so when it draws a big box, we say back up because it's too close, and if it's a small box, then go forward.
So it's not the elevation of the size.
You could do elevation.
The size of the box is calculated by the amount of the color and the whole image. So the more
so
red,
a larger red cup going backward.
But you could do X-Y coordinates. Like right now, we're just doing X coordinates and box size. That's all we cared about. But you can do Y coordinates and figure out if it's up above you, and if you need to move a servo up. You can, with the center of gravity, you can have a camera on the servos tracking left, right, up, and down really fast based on where the object moves. And I'll show you an example of that real quick. It's pretty cool. Let's see. Let me do videos. This is, let me show you this robot real quick. This is called PyRobot, and he's done different generations of it. I don't know if you've seen it. This is an Omni thing as well. And I'll show you object avoidance on this page in just a second. But the robot itself looks like this. This was the old version of it, where it was just a camera pointing up, and this is kind of what we mimicked. But for okay, for the video of tracking, I'll just show you real quick. This is pretty cool. Let's do this one. Yeah, this is it. But he's using robo-realms as well, and he's just tracking whatever color object this is. In this case, it is a red ball, I think. Go ahead and hit the lights. So you can see he'll jump in there and he'll just kick it around and it'll move pretty fast. I'm going to turn a robot real quick. So he's using robo-realms with the center of gravity module, and he's just added that line you can add if you want. It just says from the center where the object tracks to. But it's pretty quick. You can just kick the balloon around and it'll figure out where it was.
And that's on a pan and tilt.
Yeah, it's just pan and tilt camera. So that's pretty much that. But that's what you can do with object tracking.
There was one pretty interesting part in there where the color went out of the screen for a second.
Right.
And it continued in that same direction.
I think what they've done is they added a line of code in there, which is similar whenever they have like an object tracking pan and tilt. What they'll do is they'll write a line of code to, if the object goes out of that area, it continues to travel in the direction that it was going for, let's say, 2 seconds. And what they call that is similar to what animals do. If something comes out of the vision of an animal, it does that same process.
Okay. Let's hit the lights again so the robot can see and do some, this is going to be edge object avoidance. They don't have to be red objects, we just have a bunch of red objects, that's what we're using. But anything that it can see. And the problem with this robot is that the object needs to be a little bit tall Found that if it gets too close to an object that's smaller, it doesn't see it, it gets too close to it.
Out of the line of sight
Right.
of the panoramic camera.
You've got two options. You can either go low to the ground with the Omni system so that it can see things lower, or you can go really high up and then get rid of the robot, which is kind of what I did with cropping the image to kind of get the robot out of the picture. But we're right in the median for the size of the robot. If we'd gone higher, we would have been able to get rid of the base of the robot in the
So the
picture.
higher you go, the smaller the object is that you're trying to locate. So depending on what you're trying to avoid, you kind of have to pick. And there's other ways to go around it. Obviously, you can use sensors or add more cameras, but this is just, like I said, basic.
Go ahead and power down the robot, and let me get the saber tooth working. Alright, go ahead and power it up. Okay. What we're doing is we're just getting the saber tooth motor drivers to talk to robo-realms, and this is the trickiest one I've seen, and it did it. Let's try again.
The other thing we've noticed whenever we try to connect this motor driver is there's extra variables that are in the module that kind of keep it back. You might have to close it and restart it. Or disable it.
Go ahead and power it off, power it on.
I think that's just a software issue in robo-realm that we haven't.
Well, for
had
that one
too
module, I mean, I haven't had anything like that on my other robot,
Right.
but I'm using different hardware, so.
That was something, and
There we
the
go.
cool thing about robo-realm is the guy that runs it, Steven, he's pretty good about getting back to you. So if you have any problems with anything, he's really quick to solve it or give you ideas on how to fix it.
Okay, so in this case, what we're doing is we're doing the polar stuff, so it unwraps the image. Then we're doing this. What this box is this is the path, the highest middle path that it sees, and that's where it's going to, based on where the XY coordinates of that is where the robot's going to drive to. It hasn't hit a red object yet, which I'm pretty impressed with, or hit an object yet, but it's going to try to find a path, and our code is really simple. Right there, it's just going to keep going forward, hopefully, or something. We'll see. But we didn't make it very complex. We did as simple as we could.
This is all done basically between me and Jan, and maybe three sessions of like 4 hours at a time. So you could get a lot more complex with the code if you wanted to.
But what it's doing, let's just try to go through this real quick. It's doing this filtering where it sees edges, and you can kind of tell it sees these edges, and then what it does is it does a side fill where this is where the edges are is black and the white is paths. Then I wrote it so it's smoother and get rid of a lot of the little lines that it wouldn't be able to go down that path. And then I smooth it out, and then I do a point location where, let's just hit OK on that, and do point location. And all these are adjustable. And I just told it highest middle, and I said a big box so I can see where it's at while it's doing it. And then I use this variable, this highest middle variable in my code, and I say, well, this just compares the camera images, and then this code, I just say wherever that object is, turn left or turn right, this highest middle X, wherever that is, and do the motors at a certain speed. So that's pretty much that for edge following. Now, now it's kind of fun. I can combine everything into one robo file and then change what it decides to do based on a variable. So like on a web page or something, I could say find edges and avoid objects based on edges, or find blobs and avoid on blobs. Let's go ahead and kill this one and do the next one. The next one, I didn't kill it well. We'll do blob following next.
I'm going to turn it off.
That's fine. So it'll look kind of the same, except it's just instead of doing it, and I'll show you what the blobs look like. That'll be kind of fun. So go ahead and power it on.
Is it disabled?
Yeah. And wait
Give
a
it
few
like
seconds.
5 seconds.
Alright, here I go. No? Let me close it and let you turn it off and turn it on.
The cool thing about this motor driver, it's got a LED, so